launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the moon's poles, however, the temperature is always at around minus 400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color depending on various phenomena. The moon seen near the horizon will most likely be yellow or red-tinted. The rarer, blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days.
You may think the Earth is pretty big, but the Sun makes up almost 99.9% of the mass of the whole solar system. The rest of the mass is made up by the planets and their satellites, asteroids, comets, gas, and dust. It's around 93 million miles away from our planet, but it keeps us warm every day. Its temperature is about 10,000 degrees Fahrenheit, but the space surrounding it is still cold as ice. To understand this, we need to distinguish between heat and temperature. Heat is the energy inside some object. Temperature is something that tells us if that object is hot or cold. When the heat is transferred to that object, it makes its temperature go up. When the object is losing heat, the temperature goes down. Heat can be transferred in 3 different ways. The sun does it through radiation. That means it's releasing heat in the form of light. Your body radiates heat too, as infrared waves. That's why thermal imaging cameras will detect that you're in the room even at night. The hotter the object, the more heat it will radiate. The temperature only affects matter. Since space is mostly a vacuum, it doesn't have enough particles for heat to transfer in any other way than through radiation. When the heat from the sun gets to an object, the atoms start absorbing energy, but the heat can't transfer since there's no matter in space. Those rare atoms and molecules in space will absorb the heat. And they'll simply stay that way, while the cold vacuum will stay cold. There's a lot of matter inside Earth's atmosphere, so the energy of the sun can transfer easily. But if you put an object outside of the Earth's atmosphere in direct sunlight, it would end up heated to 250 degrees Fahrenheit because it's matter made of atoms and molecules. The temperature of the vacuum is negative 454 degrees Fahrenheit. That means, depending on where you are, space can either burn or freeze you. The sun isn't actually yellow. It emits light over a wide range of wavelengths. We can tell both its temperature and color by the peak in its spectrum. For instance, cooler stars will appear red, and hotter stars will be blue with yellow, orange, and white stars in between. When it comes to the sun, the spectrum peaks at a wavelength we'd usually call green, but our eye perceives it differently. So, the shade of green in combination with other wavelengths from the spectrum is going to look white to the human eye. We generally see the sun as yellow because our atmosphere scatters blue light more efficiently than the red one. During sunrise and sunset, there's more red light in the spectrum of the sun, which gives us amazing sceneries. Sunspots are part of the sun's visible surface that are on average way cooler than the sun itself. They overlap with parts that have an increased magnetic field. These parts don't allow the release of heat to the sun's visible surface. That way, the rest of the sun's surface is 3 times brighter than those sunspots. That contrast makes them appear almost black. If we could take a sunspot apart from the sun and place it somewhere in the night sky, it would be different, as bright as the moon when we see it from the Earth. All the planets in our solar system spin in the same direction because they were formed from one protoplanetary cloud, except for Uranus and Venus. They have probably had some strong impact on them that made them spin in the opposite direction. But it's different with galaxies. They don't usually form the same cloud of dust and particles. Also, they're not randomly distributed across space. They come in filaments, dense, slender strands of dark matter and galaxies, with voids in between. Proto-galaxies are linked by gravitational forces in small areas of space. This is probably because of the distribution of dark matter throughout the universe. The matter in the filaments moves in a corkscrew motion and goes towards the densest area. So, there might be a common direction galaxies tend to spin, but it's mostly random. There's a possibility we'll see a lunar elevator one day. Yep, a cable anchored to the surface of the moon. It would stretch 250,000 miles. We wouldn't be able to directly attach it to our planet because both Earth and the moon are moving. But we could keep it terminated high in our planet's orbit. Some researchers believe we could build such an elevator for a few $billion. The moon has resources we could definitely use. A rare form of helium found there could be of use in fusion power stations on our planet. Also, we could take some other rare elements and use them in smartphones and the rest of electronics. So, after around 53 trips up and down, the elevator could pay for itself. The cable would be as thick as a pencil, but its weight would be around 40 tons. It could even be made of materials we already have here on Earth, with no need to invent something. There could even be a combination of 2 elevators. A spacecraft would winch up an elevator from the surface of our planet to a space station. Then it would be flung towards the moon. There would be another elevator to finally lower it down to the surface of the moon. Planets in our solar system have predictable and stable orbits, but gas-giant collisions could have happened at an early stage when a planetary system was still forming. In case of a head-on collision, two gas giants would merge. They wouldn't end up losing their mass, the materials in their gaseous envelopes, or the ones in their solid cores. Such a collision at a higher speed would cause the loss of the major part of the envelope gas, and very high speeds, boom, both planets are gone. It's different if it's not a head-on collision. If two cores manage to completely avoid each other, gas giants won't merge, but they'll lose some of the mass. Gas giants might even change their shape due to such collisions. Astronomers found out there's a galaxy extremely far away from us that looks similar to our Milky Way. We now see it as it was when the universe was only 1.4 billion years old, and now it's 13.8 billion years old. It took over 12 billion years for the light to come from this faraway galaxy and reach our planet. This galaxy is peaceful, stable, and surprisingly non-chaotic, unlike all other galaxies that were quite turbulent in their early stages. To leave the Milky Way, we'd have to travel around 25,000 light-years away from the center of the galaxy, or 500 light-years vertically. Our galaxy is a disk of stars that spreads around 100,000 light-years across and is 1,000 light-years thick. The Sun, its central star, is located halfway from the center of the galaxy and close to the middle of the disk in the vertical direction. We'd have to go further than its edge to get away from the halo that surrounds the Milky Way, old stars, diffuse gas, and globular clusters. If you wanted to go even further to see the Milky Way in all its glory, you'd have to travel 48,000 light-years vertically. At this moment, we don't even have a telescope we can send there. There are central stars that eat planets. Our solar system is stable, unlike many other planetary systems. So we don't have to be afraid the Earth or some other planet will change its orbit and go towards the Sun. But at least a quarter of other planetary systems with orbiting stars similar to the Sun have a pretty chaotic past. In some of them, there are planets that used to move around, and their unpredictable migrations have disrupted the paths of some other planets, or even pushed them outside of their orbit. That means some planets probably have fallen into the central star. When that happens, the planet gets dissolved in the outer layer of the star, which means it gets eaten.
It's probably one of the worst nightmares for an astronaut, to float away to outer space without any hope to return. Just imagine slowly moving away from the International Space Station into an endless black void because of some accident, somewhere where there's absolutely nothing but a cold vacuum. Fortunately, you still have an opportunity to survive. Let's have a detailed look at the moment when this can happen. So, you're on the International Space Station. It's now at an altitude of about 250 miles in the upper layers of the atmosphere. It's important to mention that it's not just hanging out there in space. Earth's gravity is constantly pulling on the station. Not to fall, the station needs to fly around our planet at a speed of about 17,000 miles per hour. That speed is fast enough to help the station fight the planet's pull. But on the ISS, when you go into outer space, you don't feel this speed. It seems to you that you're floating in one place, watching Earth spin. But there's still a lot of space debris that moves in the opposite direction. From the point of view of a person on the ISS, the speed of these objects is incredibly fast. You put on a spacesuit. It has oxygen supplies and is equipped with a water compartment so you can drink during the mission. So, you're about to walk into space. First, you need to go through a special door called an airlock. Once you're inside, you see that there are two doors here. You enter and close the first door to block access to the space station's oxygen. Then you open the door leading to space. What you're about to do is called a spacewalk. There are several reasons why you might be in outer space right now. You may be conducting scientific experiments to find out how different things behave in space. Also, you can be testing new equipment, sensors, and other high-tech gizmos. Another reason might be the repair of failed parts or routine maintenance of the International Space Station. Before taking a step into the void, you attach your spacesuit to a rope connected to the body of the ship. You can also fasten small cables to your tools, such as a screwdriver or a wrench, so that you don't lose them. You push off the ship and experience a feeling similar to swimming underwater. By the way, before going out into a zero-gravity area, astronauts train inside a huge swimming pool. You hold on to the parts of the ship and head to the place that needs to be repaired. Let's say you need to tighten a small screw. One astronaut once said that any work in outer space is difficult. You're wearing a huge suit that slows down your movements and makes you clumsy. It also makes your skin itchy. The work can last up to several hours. During this time, you sweat a lot. One of the spacesuit filters may be broken. In this case, all the fluid released by your body can spread all over the suit and reach your face. Your eyes may start watering. Tears will make your vision blurry. As you see, dozens of dangers are lurking out there in open space, and there are no clear instructions on how to deal with most of them. Anyway, you're tightening the screw, but something goes wrong. The wrench jumps out of your hand, and the screw flies out of the hull of the ship. You try to catch it and accidentally push off the station. You manage to grab the screw, but your body is already flying away. You have nothing to hold on to, but you have the rope. And oh no, it's not tied to your spacesuit anymore. You've attached it incorrectly. Now you're not just flying away from the station, your body is also spinning. The views of blue Earth and black space switch in front of your eyes. You can't stop. Fortunately, the cable is not the only safety measure. Your spacesuit is equipped with a SAFER, Simplified Aid for EVA Rescue. This is a backpack with fuel that works like a jetpack. You activate the backpack, and it levels your flight. You stop spinning and calm down a bit. Now, you know exactly where the ISS is located. Next, you have to choose the direction manually and fly up to the station very carefully. The SAFER releases gas from small tubes, and this makes you fly forward. Using the SAFER control panel that looks similar to a joystick, you can change the direction in which the gas is released. This way, you'll steer your spacesuit. Make sure the station is in your line of sight. Press the joystick to activate the tubes, but take your time. You have to stabilize your forward movement. Pressing the wrong button can cause you to spin again, and this will reduce your chances of returning. Each astronaut spends many hours in a virtual reality simulator that makes them feel like being in outer space. So know how to control the SAFER. You're approaching the station at a slow pace. Don't let the backpack speed you up. If you start to accelerate, you need to point the tubes in the opposite direction to slow yourself down. If you fly too fast, you can crash into the station and damage the spacesuit. You've finally arrived at the ISS. You need to cling to something and move toward the airlock. You feel as if you're climbing a mountain underwater. You get to the airlock. Phew! Well, let's go back in time to the moment when you were flying away from the ISS. So, you tried to use the backpack to level your movement. You're nervous and can't calm down. You randomly press the joystick and chaotically direct the tubes in different directions. A few minutes pass. You haven't come closer to the station, and the fuel in the SAFER has run out. Now, you're even more nervous. Let's go back in time again. You float away from the ISS. Then use the SAFER and slow down the rotation speed of your body. Now you're facing the ISS. You approach the station with slow but steady thrusts. Everything is going well, but at one moment, you notice some movement. This is a small piece of metal from an old satellite. It crashes into the SAFER and slices through the backpack. Fuel starts leaking out into space. You start spinning again because of the impact. You don't understand which way you are moving. All you need now is to take a deep breath and use the remaining fuel to stop. Done. You're floating without rotating. There are no instructions and protocols that will help you get out of this situation. You're moving in outer space and can control this process. To return to the ISS, you need to push off something. Fortunately, you have time to think about what to do next. Your spacesuit has oxygen reserves that are enough for several hours. Also, you have water. You can drink it through a small rubber straw attached to the inside of your helmet neck ring. You're the first human in history who got into such a situation. But this doesn't mean there's no chance of survival. If you could throw something to the side, it'd set you in motion. For example, if you had a heavy wrench, you could throw it in the opposite direction from the ISS. This way, you'd launch yourself toward the station. But unfortunately, you have nothing to throw. You have your broken SAFER, but you can't remove it without another person's assistance. You enjoy the beautiful view of Earth and try to breathe as slowly as possible to save oxygen. It seems there's no chance left for you. But at this moment, other astronauts call you using the radio. They see your location and are going to save you. Your colleague is heading in your direction. She's attached securely to 2 long cables. She's going to give you one of them when she reaches you. Using the SAFER, the astronaut flies in your direction. She's very close. Finally, She slows down and grabs your hand. She unhooks one of the cables from her spacesuit and attaches it to yours. Using the cable, you approach the station. At this moment, a rusty bolt flies by. The main danger is that space debris can break through your spacesuit and tear the rope. You accelerate and reach the airlock, and then you open the door and dive inside. One of the most dangerous space missions has been completed. Theoretically, there's another way to save you. A spacecraft delivering food and air supplies to the ISS can pick you up and bring you back to the station. But this mission is even more difficult, as it requires a very precise route calculation. If something goes wrong, the spaceship can kick you. In this case, you will fly away at high speed. You can travel for several hours until you run out of oxygen, or a piece of space debris destroys your spacesuit. Fortunately, all astronauts are well-trained and experienced enough to avoid such accidents.
Imagine flying in a spacecraft in a cloud of asteroids at high speed. You dodge one more, and then hit the gas pedal to the floor and crash into an asteroid at full speed on purpose. This is exactly what NASA is going to do in the near future. The entire mission will begin at Vandenberg Air Force Base in California on November 24th. Let's follow it step by step. So, the Falcon 9 booster rocket is already on the launch pad. It's as tall as a 22-story building, or 11 giraffes, and it can get about 8 tons of cargo into orbit. So you could send a big elephant into space, and a supply of food for it. Countdown, 3, 2, 1, ignition! Smoke clouds everywhere, and the rocket begins to gain altitude. 9 engines are working at full power to accelerate the rocket. At its peak, it reaches speeds 10 times faster than the speed of sound. And then, the rocket engines shut down, and the rocket's first stage undocks to return to Earth. A couple of seconds later, the second stage receives the ignition command. It turns on its one engine and climbs even higher to orbit. The cargo capsule then opens and releases the DART spacecraft. DART stands for Double Asteroid Redirection Test. Once released, the spaceship deploys 2 large solar panels. It'll convert solar energy into electrical energy to power a revolutionary ion engine. Conventional engines create thrust by burning tons of fuel and ejecting it outward. The rocket itself is essentially pushing off the emitted gases. The ion engine will not burn fuel. It'll use a strong electric field to accelerate the ionized gas. Like conventional rockets, it'll eject this gas and create thrust by repelling it. And though the ion engine produces less thrust, it can accelerate the spacecraft to higher speeds. So regular rocket engines have an excellent performance on the road. They push the pedal to the metal, burning a bunch of fuel, while the ion engine slowly accelerates. But when a conventional rocket needs to make a refueling stop, the ion spacecraft will whiz past the regular one at insane speeds. So the DART spacecraft begins its year-long journey. By comparison, a flight to Mars would take about 7 months. Fast forward 1 year ahead, and we've arrived. This is the asteroid Didymos. The far point of its orbit is 2 astronomical units from our star. That's 2 Earth-Sun distances. At this point, the Sun begins to pull the asteroid back, and then it approaches the closest point to the star, 1 Earth-Sun distance. That is, its orbit lies very close to the orbit of our planet. Didymos made its closest approach to Earth at a distance of about 4.8 million miles. That's 20 times farther than the Moon's orbit. It takes 770 days to complete one such revolution around the Sun. So, Didymos is not considered a hazardous asteroid, but in the future, it'll approach the Earth even closer, and the consequences of a collision with it could be catastrophic, given its size. It's bigger than 2 Empire State Buildings, and it rotates at a rate of 1 revolution in 2 hours and 15 minutes, so it has a tremendous amount of energy. Plus, it has an asteroid companion. It's a small pebble 520 feet wide. It's like 12 school buses or 10 train cars. Its orbital period, that is, the time it takes the pebble to make a complete circle around the asteroid, is about 11.9 hours. NASA believes that asteroids up to 80 feet wide are likely to burn up completely in our atmosphere due to friction with the air, so they're not hazardous. Asteroids between 80 feet and half a mile in size will not burn completely and could cause severe damage. And asteroids over half a mile have the potential to wipe out large cities or even entire states. In that sense, we can consider Didymos potentially hazardous. So we're going to test one way of defending against asteroids on it: kinetic impact. That's why we sent DART here. So our spacecraft is going to hit an asteroid, only not its main body, but its little companion. DART is already moving toward it at about 4 miles per second. At that speed, a trip from New York to Washington, D.C. would take less than a minute, and a trip across the United States from coast to coast would take about 10 minutes. DART is getting close. 3 seconds to impact. 2, 1, BAM! The spacecraft crashes into the asteroid at full speed. What are your predictions? Asteroid explodes and is blown to pieces? Or asteroid flies off the main body into space like a billiard ball? Well, scientists predict that this collision will reduce the speed of this small asteroid by a fraction of a percent, but it'll still be enough to reduce its orbital period by a few minutes. Then our telescopes on Earth will be able to study the effects of the collision in more detail. And to learn even more, we'll send another spacecraft to Didymos on another mission. This is Hera. It'll be launched in 2024 and is scheduled to arrive at Didymos around 2027. This spacecraft will carry a bunch of research equipment to assess the collision damage done by DART. When it arrives, Hera will take many pictures of the small asteroid, including a fresh impact crater. Hera will also be carrying 2 CubeSats. These are miniature space probes, smaller than a shoebox. It'll launch these mini satellites, and they will make an even closer approach to the asteroid. They will study this space rock for 3 to 6 months. At the end of the mission, one of them will attempt to land on the asteroid's surface to learn even more about its composition and internal structure. It's also possible Hera will carry a mini impactor. This thing will have to make another impact on the asteroid. Then scientists will be able to evaluate the difference in impacts with a large spacecraft and a small one, and understand how we can defend against asteroids in the future. In theory, we don't need to send a giant rocket to a dangerous asteroid to destroy it. A single strike might be enough to shift the trajectory of the asteroid slightly. On a cosmic scale, changing the trajectory, even by a fraction, would dramatically change the asteroid's finish point. But kinetic impact is not the only way to deal with hazardous asteroids. Check out the gravity tractor. For this technique, we need to send a spacecraft toward the asteroid too. Only it won't crash into it. It'll have to go into its orbit. Any asteroid has a force of attraction, and it'll pull the spacecraft toward it. But the spacecraft's engines will keep it at the same altitude, so the asteroid itself will start attracting to the spacecraft. This method is reliable enough, but it takes a long time. And it'll only work if we detect a potentially hazardous asteroid many years before it arrives at Earth. We should have enough time to send a spacecraft to the asteroid and then carry out an asteroid tractor technique. The other option is a laser. When an asteroid is found, we need to aim a powerful laser beam at it. It'll heat up a certain point on the asteroid, causing the material there to evaporate. This is where physics comes into play. The material on the asteroid evaporates upwards. It makes the asteroid itself move downward. Just like our rocket engines work, the burning fuel is ejected one way and the spacecraft moves the other. We can also use solar power instead of lasers. To do that, we need to build a big space station, which would be equipped with a lot of magnifying glasses. Have you ever tried to burn letters on a wooden surface with a magnifying glass? Well, we'd be doing the same thing, but with an asteroid. The space station will have to focus lots of the sun's rays into one point on the asteroid. Again, the material evaporates because of the high temperature, and this causes the asteroid to change its trajectory slightly so that it flies past our planet. How about foil? That's right, we can avoid a collision with an asteroid by using ordinary foil. We would have to wrap the asteroid in the same reflective material. Then the asteroid won't absorb the sun's rays, but will instead reflect them. This creates a little pressure on the surface of the asteroid. It's as if the sun's rays are pushing the asteroid, and it'll be able to change its trajectory. And not the most obvious but reliable option is conventional rocket engines. We can put several powerful engines on the asteroid. This would create thrust and change the trajectory of the asteroid. And if there are enough engines, we can even take control of the asteroid. So when a bigger space rock appears on the horizon, we'll turn on our engines and point the asteroid straight at it. Such a collision can completely destroy even a very large asteroid, and it would make for one epic light show.
Hello, Brightsiders! Today, we have a very unusual topic. We are discussing toilets in space. Do you know that the first astronauts didn't have a toilet at all? The first American astronaut and the second man in space, Alan Shepard, found himself in a very awkward situation. His flight was only supposed to last 15 minutes, so the engineers didn't install any toilet inside his spacecraft. Shepard took his seat in the spaceship about an hour before the scheduled launch. But due to weather conditions and technical problems, the rocket launch was delayed by 2 hours. Alan Shepard was lying on his back in the spaceship all this time. At one point, he felt the need to go number 1. He reported it to ground control, but if Alan Shepard got out of the rocket to do his business, it would delay the rocket launch indefinitely. So, ground control didn't let him out of the rocket. The only option for him was to try and relax. In the end, he did his business right inside his suit. It's a good thing his spacesuit and the clothes underneath were made of cotton, which is quite absorbent and soaked up all the liquid. So, Alan Shepard completed his flight in comfort and relatively dry. Though he still needed to turn off the sensors in his suit because if they got wet, they could cause a short circuit. But the first man in space, Yuri Gagarin, managed to solve the same problem before the rocket was launched. When he was transported to the rocket by bus, a couple of minutes before they arrived at the rocket, he asked for a stop and relieved himself. This way, Yuri Gagarin made his nearly 2-hour flight in comfort. So remember, always go to the restroom before a long trip. Later, NASA took care of astronauts' call of nature using the following device as they sent people into space on more extended missions. It consisted of a cylinder that an astronaut had to put on. Astronauts placed this system on straps near their waists. This cylinder was connected to a bag that collected all the waste. That was the first NASA toilet. Comfortable and cheap. NASA also tried to experiment with astronauts' diets. It was all about slowing down the digestive process and prolonging the time between eating food and drinking water to produce waste. One of the astronauts, John Glenn, tried this method out. His flight around Earth lasted about 5 hours. A special diet and medication allowed the astronaut to avoid the call of nature for a relatively long time. He did his business right before re-entering the atmosphere. When scientists analyzed his waste, they found out that its volume was 35% more than the average person's bladder could hold at maximum capacity. But the astronaut had no complaints about his condition, and he said the flight had been quite comfortable. I know that now when astronauts spend time inside a space station or a spacecraft in outer space, they sometimes wear their spacesuits for up to 9 hours. It means that using the regular toilet on board isn't really an option. The solution to this problem is simple: diapers. They are more advanced than the ones sold on Earth, of course, with a special absorbent sewn into the fabric. It can keep an astronaut's body dry for a long time. As you already know, I'm a high school teacher. If we went with my students on a school excursion to the International Space Station, the first question they would ask would probably be, "Tom, where's the restroom?" Well, of course, they would be also excited to learn about the cosmos, but it turns out that using a restroom in zero gravity might be quite a challenge, for which one needs to be prepared. If you take a hose in your backyard and start watering your flowers, the water comes out in a solid stream. The gravity captures it and falls where you aim. And in space, as you know, there's almost no gravity. so the water that comes out of the hose keeps flying in the same direction. And if you have to hit a precise target, it's even more difficult. The stream can break into droplets. They will start bouncing off the walls, going down and flying up. So if you're trying to use a regular toilet in space, you would be surrounded by flying droplets. The solution to this problem is to create a force that will attract the waste. If not gravity, then vacuum. Like the one we have in airplane toilets. After pressing the flush button there, you always hear a humming sound. That's the fan that starts pumping the air out of the waste tank. When the pressure is low enough, the hole in the drain opens and all the waste is instantly pulled down. And this is how the space toilet works at the International Space Station, where you have to create such vacuum from the very beginning. This way, the hose water will form a stream, not because of gravity, but the air pulled inside by a fan. Oh, and regular toilets won't do. If you need to use the bathroom on the ISS, you need to take a hose and turn the toilet on with a button. The fan inside will start spinning, pulling in the air. You'll do your business essentially into a vacuum cleaner. There's a unique funnel-shaped hose end so that both men and women can use the toilet. A suction air stream picks up all the droplets and directs them into the tank. Then comes the whole waste cleaning system with many filters and chemicals. There's also a tank of powerful acid. It's there to dissolve any solid formations in the waste. Otherwise, they can clog the filters and valves and complex systems and cause a breakdown. A leaky toilet is a very unpleasant thing when you're locked in a tight space without gravity. That acid can easily dissolve even some metals. That's why space toilet materials are made of special titanium alloys, super resistant and very expensive. After being cleaned, the waste gets turned into drinking water. It means that with time, you'll turn it into the garbage again and the cycle will repeat and repeat all over. Don't worry, the purification system works exceptionally well, so there's no harm in drinking the water. And your coffee also won't taste any worse. Things are a little more complicated if you run to the toilet for number 2. Then, just like on Earth, you'll have to lift the toilet lid first. At this point, the same fan as in the previous case turns on. It should already be working to prevent bad smells. Then it would help if you sat on the toilet, and here's another challenge. It's hard to do it in zero gravity. So there are straps for your feet and handles to hold on to. The fan does its job and your business goes into the waste tank. Paper and tissues go in there too. Each portion of solid waste then goes into a bag and gets sealed. And then the system sends these waste bags to a special canister. These canisters are stored on the ISS until a cargo spacecraft arrives there. The astronauts receive food and water supplies and scientific equipment. Then they load the cargo spacecraft with canisters of human waste and other garbage. After that, it undocks and prepares to return to Earth. But since cargo spaceships burn up entirely due to friction against the air in the upper atmosphere, all the waste gets disposed of before reaching the planet's surface. Another option astronauts have is to throw the canisters with waste directly into the open space. Earth's gravity eventually attracts the containers and they too burn up in the atmosphere. Currently, NASA is developing a system that could recycle waste of number 2 into water. After all, water is a precious resource on the International Space Station. So this space toilet, which is a little thing about the size of a scooter, costs around $23 million. That includes manufacturing and a dozen years of development. And this price doesn't even include the delivery to the International Space Station. For that money, you could buy a Bugatti Veyron, the most expensive car in the world, or something similar. Or a private jet, for example. Or you can become an island owner. You can even buy a few of them for that money. But okay, let's get back to space. The journey starts at the launch pad. The rocket that will later deliver the cargo to the ISS is assembled. Ignition! The rocket engines turn on. They burn hundreds of pounds of fuel every second. The rocket goes up, and when all the fuel is burned, the rocket's first stage undocks. It returns to Earth and makes a soft landing. The booster can be used again after refueling. Once the booster is undocked, the rocket's second stage fires the engines. More fuel is burned so that the rocket can reach the ISS altitude of about 250 miles above the sea level. Once in orbit, the cargo spacecraft docks with the ISS, and voila! The space toilet is delivered. But it costs about $50 million to launch a booster rocket like Falcon 9. We also plan to send people to Mars, and the trip will take them about 7 months. So we should create a comfortable bathroom for the astronauts probably. The design of the 23 million toilets is bound to be improved. Let's wish the engineers to make it smaller and lighter, so this way it uses less space and saves more fuel. Thank you for watching today, Brightsiders, and remember, let's learn something new every day together with Brightside.
All aboard! This is the Intergalactic Cruiser. The destination on your ticket is a tour of the local group of galaxies, featuring the large and small Magellanic galaxies, the Orion Nebula, the Andromeda and Triangulum galaxies, and a few surprises in between. Tickets, please. Be advised you may experience a slight tingling sensation as we rev into hyperspace. The ship and everything in it is going through a dimensional phase change. It's nothing to worry about. The tingling passes quickly. Now, passengers, as we head toward galactic latitude 180 degrees north, as Terrarians are accustomed to calling it, our first main item of interest will be an intense star-forming region known as M42, the Orion Nebula. But first, a special treat by the captain that's not on the advertised itinerary. The Horsehead Nebula. It's off to the port side. That's left for you Aggies. Its designation is M43. The newborn star at the top of the Horse's Head has a strong solar wind that is deforming the shape of the nebular cloud. Get a good look at it now, because in a few thousand years, those gases will be completely blown away by the star-like nebula that made our sun. Yep, long gone, except for the nebular gases captured by Jupiter, Saturn, Uranus, and Neptune. Okay now, one of our junior explorers asks a question. What is the M in M42 and M43? Well, young lady, the M stands for Messier. Pronounced Messier, not Messier, as in, is your room messier than mine? Charles Messier to be precise, was a French astronomer in the 18th century. He published a catalog of 110 fuzzy objects as seen through an early telescope. The Horsehead Nebula is number 43 on his list. We'll see more M's as we continue our tour. Heads up, we're coming to the Orion Nebula. The gases in the nebula may seem less colorful than you expect. That's because we're accustomed to seeing long-exposure telescopic photos and enhanced photos designed to highlight the different gases in the nebula. May I suggest using the pair of tinted glasses that come with your onboarding packet if you want to heighten your experience. In we go! Now, it's a good thing we are in hyperspace. As we approach the trapezium star cluster in the center, the bright star, Theta C, sends out a solar wind at 5 million miles an hour. It sculpts the whole cloud of gas and dust, creating shock waves that compress nearby stars. Theta C is a megastar, 200,000 times brighter than the Sun. It will go supernova in about 1 million years. I won't be around then. Oxygen, hydrogen, and sulfur glow in ionized states like a fluorescent light bulb. Oxygen blue, hydrogen red, some green and sulfur, and dust glow as yellow-orange. As we pull out of the Orion Nebula and rise high above the galactic plane, the spiral arms of the Milky Way are visible. Our sun, which you cannot distinguish from this height above the galaxy, is in the Orion spur that lies between the outer Perseus arm and the inner Sagittarius arm. Notice the center of the Milky Way contains a bright magnetic bar that plays an essential part in star formation. Over 70% of nearby galaxies include magnetic bars. It's a sign of a mature galaxy. Only 20% of distant galaxies contain magnetic bars in their cores. Which reminds me, passengers, the juice bar is now open. Our H1 server will take your orders. Now, that's the Andromeda Galaxy far, far out to the port side. But may I call your attention to the many dwarf galaxies, over 40 of them, that populate our galactic neighborhood. We're heading to one now. The Large Magellanic Cloud, LMC to astronomers, is an irregular dwarf satellite galaxy of the Milky Way, containing about 30 billion stars with a dynamic star-forming region called the Tarantula Nebula, which we will be cruising through shortly. Of course, if there is a large Magellanic Cloud, there must be a small Magellanic Cloud, SMC. And there it is, below and to the left of the LMC. The Milky Way will eventually ingest both dwarf galaxies. Some prefer the word accreted, but the result is the same. If you use your tinted glasses again, you can see that the LMC has stripped away a tremendous amount of gas from the SMC, as they have interacted gravitationally over millions of years. Hey, I know all about gas. Now we're heading out of the Milky Way to a distance of about 50 kiloparsecs. That's 50,000 parsecs, or about 163,000 light years. So, what's a parsec? No, it's not slang for pair of socks. A parsec is about 3.26 light years. A light year is about 5.88 trillion miles. The word parsec is a combination of two words, parallax and second. Parallax is the shift an object seems to make when viewed from two different perspectives. Looking at an object with your left eye and then your right eye, you'll see the object appear to shift. That's parallax. When an astronomical object is photographed with the Earth on one side of the Sun, and then again 6 months later on the other side of the Sun, the shift is measurable in degrees of arc, or minutes of arc, or seconds of arc, down to milliseconds of arc. That's a parsec, a parallax of 1 arc second, which turns out to be 3.26 light years. Hey, what about a Joan of Arc? That's how you measure distances in France. Ha ha! Meanwhile, since you can't measure a light year with a ruler or a tape measure, parsecs are the scientific way of telling the distance to a star or intergalactic object. The greater the parallax, the closer the object is. The smaller the parallax, the farther away it is. Now, straight ahead in the heart of the Tarantula Nebula is the R136 star cluster. Within a distance of 1 light year, there are over 40 stars each with a mass over 50 times that of the Sun. Wow! Comparatively, there isn't a single other star within 4 light years of our home star, Sol, and that's a good thing. You can see supernova 1987A at about 2 o'clock high. A blue giant star, 100,000 times brighter than the Sun, experienced a core implosion, resulting in a Type II supernova 100 million times brighter than the Sun. It has left behind a neutron star, clouded in dust and gas, and a wildly spectacular display of fireworks. Now, 1987A in the Large Magellanic Cloud is the closest supernova to Earth since 1604, which happened in the Milky Way about 20,000 light years from Earth. It was visible in the daytime for about 2 weeks, or so. After 1987A went supernova because it was a blue giant star, speculation has increased that the blue giant star Rigel, the foot star of the constellation Orion, might go supernova in the not-too-distant future, or already has gone supernova. Rigel is approximately 860 light-years from Earth, so anything that happens to Rigel would take about 860 years before it would be noticed on Earth. Supernova 1987A ejected the heavy elements like cobalt, nickel, and iron and lighter silicates into the Tarantula Nebula, where they will form the basic building blocks of stars and planets. Our server is now offering space-themed snacks. May I recommend the Jupiter Cotton Candy Puffs for the children on board? Remember, I know all about gas. Our next stop is the Andromeda Galaxy and environs. Notice its halo as we leave the Milky Way and its 300 billion stars behind. As many as 150 globular clusters reside in the galactic halo. They orbit down and through the galactic disk and contain some of the oldest stars in the universe. How they got here in our home galaxy is a matter of intense study. You will notice NGC 6822, an irregular dwarf galaxy off to the starboard. NGC stands for New General Catalog of Astronomical Objects. Now you'd think there'd have been an old general catalog, but there wasn't. It was just a new catalog. There is, however, a revised new general catalog which astronomers refer to regularly. Clears that up, huh? As we pass NGC 6822, you'll notice a magnetic bar beginning to form and bright patches of new star formation. This galaxy was discovered in 1884 by E. Barnard and is also called Barnard's Galaxy. Mr. Barnard was quite an astronomical observer. He has a crater on the moon named for him, one on Mars, an area on Jupiter's moon Ganymede, a minor planet, number 819 Bernardiana, and the star with the fastest movement across the sky, Bernard's Star. Now, not too many people have their name emblazoned across space, as has Edward Emerson Bernard. Approaching the giant Andromeda Galaxy with its trillion stars, we will skirt above its western edge and visit one of the enormous galaxy's dwarf companion galaxies, M110 or NGC 205. Yes, it also has two designations. Hey, take your pick. The first of its kind, a dwarf spheroidal galaxy of about 3.5 billion solar masses, M110 or NGC 205 if you wish, has 8 globular clusters near its core. It too will be swallowed, or accreted if you prefer, by the Andromeda Galaxy. It may have already been stripped of much of its stars and gas, a point highlighted by M110's general lack of star formation. Everybody having fun yet? And now, our final stop, M33, the Triangulum Galaxy, the third and last spiral galaxy of our local group. Located in the small constellation of Triangulum, Latin for triangle, good guess, M33 is about half the size of the Milky Way. The Triangulum Galaxy is 2.7 million light-years from Earth, but it is much closer to the Andromeda Galaxy and moving towards it. If two spiral galaxies collide, it may alter the course of the Andromeda Galaxy and prevent the predicted collision with the Milky Way. Well, let's hope so. Now, this important message. We will serve dinner on our return trip to Earth. There's a choice of chicken or fish. We hope you have enjoyed the tour. Hey, if you fill out our survey and give us 5 stars, you can also have dessert.
They say somewhere out there, there's a pen that can work in zero gravity, at extreme temperatures, and even underwater. They say this pen can write on almost any surface, or if you turn it upside down, or when your surroundings are heated up to 570 degrees Fahrenheit. They say NASA spent millions, or probably billions of dollars, and almost a decade to develop such a pen. The problem with ballpoint pens in space is that they don't work in the conditions of weightlessness. The ink can't flow to the ball normally since gravity doesn't affect it. Instead, pressure is created in the ink reservoir and pens start leaking. Some time ago, NASA used pencils, but wooden pencils were considered to be a fire hazard in most spaceships. All because, at that time, the atmosphere inside them was 100% oxygen. The need for a super pen was obvious. But whatever the rumors claim, NASA did not create such a pen, spending a fortune on the research. Its development was sponsored by Paul C. Fisher of the Fisher Pen Company based in Chicago. He spent over $1 million in almost 10 years to make a pressurized ink cartridge. It was supposed to allow space pens to function in zero gravity and other extreme conditions. Eventually, they got a pen that could write at a temperature of -30 to 250 degrees Fahrenheit, which is really impressive, isn't it? The pen was patented in 1966, and 1 year later, after conducting several thorough tests, NASA started to provide Apollo astronauts with such pens. Interestingly, the rumors about NASA spending an insane amount of money on the development of space pens have been circulating for decades. They have been debunked many times, but they appear again and again. Many sci-fi movies can make you believe that everything happening in space is accompanied by some kind of a sound effect, which is a totally false misconception. In space, no one will hear you scream. You know why? There's no air in space. It's an almost perfect vacuum. And sound waves don't travel through a vacuum. They can't reach your eardrums and make them vibrate, sending signals to your brain. But it's a good thing, especially for astronauts on spacewalks. If not for the quietness of space, they would be constantly overwhelmed by the noise of solar storms. Here's another one. All comets have beautiful long tails. It's nothing but a popular misconception. In reality, comets are very difficult space bodies to spot. They usually spend large amounts of time far away from stars. There, in the darkness of space, they remain rather inactive and completely frozen. Comets only get tails once they come close to a star. That's when they start warming up. This process makes them form some kind of a cloudy atmosphere, which is called a coma, and a distinctive tail. The tail always points away from the star that influences the comet. It happens because the tail gets blown in the opposite direction by solar radiation and solar winds. That's why the tail can often be in front of the comet, not trailing after it. Now, let's look at a light year. This very notion makes us believe we speak about time here. But in reality, light years measure distance. NASA's definition of a light year goes like this. The total distance that a beam of light moving in a straight line travels in a year. And since light moves at a speed of 186,000 miles per second, a light year equals almost 6 trillion miles. Hey, do the math. Now, people often believe that in space, you experience zero gravity. Hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit Earth, and the Sun doesn't float away from our home Milky Way galaxy. But the astronauts on the ISS experience not full-fledged, but microgravity, which means very small gravity. The gravity on the space station is only 10% weaker than the gravity on Earth's surface, but astronauts are constantly in freefall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they're very different things. Now, it may seem as if the sun is always on fire. At least that's what it looks like in pictures. But in reality, our star is a giant ball of gas. Hey, I can relate. Nuclear reactions happening in its core at all times makes the sun burn. Every second, hundreds of millions of tons of hydrogen are converted into almost as much helium. During this process, huge amounts of energy are released as gamma rays. Then these rays turn into light. In other words, the sun does emit blinding light and incredible heat. But it's not actually on fire, because no oxygen is involved in the process. A human can explode if they get into open space without a spacesuit. Well, contrary to popular belief, taking off a spacesuit during a spacewalk won't be as dramatic as it's often pictured in movies. A person will lose consciousness due to a lack of oxygen after 15 seconds of being in outer space without protection. Before it happens, the person should breathe out as much air as possible. Otherwise, this oxygen will damage their lungs from the inside. Then, without the protection of the spacesuit, which is like a mini spaceship, the pressure inside their body will drop. This will cause even more serious troubles. And even though this person definitely won't burst, they won't want to stay outside for too long. Black holes are giant, scary cosmic vacuum cleaners, they say. But in reality, black holes are more like fly traps. They don't look for things to munch on. Instead, they sit out there quite passively. Only when a star comes too close does a black hole spring into action. Even so, Only those space objects that cross a certain border get ripped apart. If the Sun were suddenly replaced with a black hole, Earth's orbit wouldn't change. At the same time, Earth's temperature would be different. There would be no solar wind, and no magnetic storms created by the Sun would affect our planet. And let's say the black hole that replaced the Sun had the same mass as our star. Then, according to the law of physics, Earth would have to come very close to get pulled into this black hole. Now, the dark side of the moon myth was debunked more than 50 years ago. And still, not everyone knows that this dark side is simply part of the Earth's natural satellite that faces away from our planet. By no means is it darker than any other region of the moon, and sunlight falls equally on all sides of the satellite. It only seems dark because we never see this side of the moon from Earth, all because of the phenomenon known as tidal locking. Over billions of years, let me say that again, billions of years, the gravitational connection between our planet and its natural satellite has changed their orbits. The speed at which they move has also become different. And since Earth is way bigger than the Moon, the satellite's rotation was gradually slowing down, until at one point it reached the point of balance. And now, it takes the Moon the same time to make a full rotation around its axis and to fully orbit around Earth. Now, you might have heard people referring to Venus as Earth's twin. It's true that both these planets are of almost the same size. They have similar mass and composition. The surface gravity on Venus is 91% of that on Earth. So, if your weight was 100 pounds on our planet, on Venus you'd weigh 91 pounds. And still, calling these planets twins is a step too far. The atmosphere on Venus is 100 times thicker than that on Earth. Plus, its surface temperatures are insanely high, up to 850 degrees Fahrenheit. That's hot enough to melt lead or burn up your pizza. Venus has no water oceans or any life forms. It also rotates backward compared to all other planets of the solar system, including Earth. By the way, another myth claims that Mercury is the hottest planet in the solar system. After all, it's the closest planet to the Sun, but Venus is actually hotter. Asteroids strike Earth much more often than people tend to believe. But most of these collisions aren't history-changing extinction events. Most of them go completely unnoticed. Most asteroids that approach our planet are qualified as small near-Earth objects. They usually burn up in Earth's atmosphere before they even have a chance to wipe out life off the surface of the planet. Not that they're big enough to do that. And still, around 40 to 80 tons of space debris fall on Earth every year. Most of this debris is tiny asteroids, also called bolides. They're usually no larger than 65 feet in diameter. That's small? Yeah, says so right here. Okay. Now, as a child, weren't you taught not to play with your food? Well, apparently these astronauts weren't. Floating Jell-O cubes across the cabin while in zero-G is a lot of fun. But it is also a sign of a potential problem called space euphoria. No one ever considered that extreme happiness in space could become a severe problem, but it can become a serious problem, and that's no kidding. For many years, space euphoria went undetected, although it was right there, front and center for all to see. When Apollo 14 astronaut Alan Shepard smuggled golf balls onto the moon and tried to create a tiny moon for the moon by attempting to hit a golf ball into orbit around the moon, everyone thought it was funny. Apollo 16 astronaut Charles Duke thought it would be funny if he tried to compete with the 1972 Olympic athletes back on Earth. He attempted to outjump the Olympic athletes to benefit from the 1/6 gravity on the moon. Duke jumped so high that he rotated onto his back and fell crashing onto the life support system in his backpack. It could have been a fatal fall if the bag had cracked. Duke's commander, John Young, said, "That's not funny," and it sure wasn't. Yet, when Apollo 17 astronauts began dancing and singing children's nursery songs while collecting rock samples, everyone still thought it was cute. Space euphoria again went unnoticed. As early as 1965, when Ed White became the first American to walk in space on a tethered spacewalk, his space euphoria became evident. He stayed out much longer than was necessary to test his mobility with the very first jetpack, or MMU as it was called, officially the Manned Maneuvering Unit. In his own words, "I'm not coming back. This is fun." Finally, when ordered to return to his Gemini spacecraft, Ed White said it was the saddest day of my life. Obviously, something sinister is at work with space euphoria. Weightlessness, combined with the view of Earth passing below, creates an exhilaration that overcomes all sense of duty. It is the great danger of space euphoria. Now, in hindsight, the effects of space euphoria could be seen when Apollo 17 astronauts drove the lunar rover on the moon. They exceeded the recommended speed limit and could be heard whooping and yelling as the rover rocked onto two wheels, even becoming airborne at times. Canadian astronaut Chris Hadfield was busy at work during his tethered EVA, extravehicular activity, when he paused to look over his shoulder. The glory of space smacked him in the face. He was so emotionally overwhelmed at the magnificent beauty of the Milky Way galaxy that tears began to fill up Hadfield's eyes. Now in space, tears do not flow down your cheeks, they pool up in your eyes. Hadfield had become blinded by tears of joy. But Hadfield, against protocol, refused to tell his supervisors on Earth. Only after he was no longer able to work did Hadfield speak a famous quote, "Houston, I have a problem." It was a direct result of space euphoria. Astronaut Hadfield managed to get back into the space shuttle, but his EVA was not fulfilled. Space euphoria had interfered. There is another aspect of space euphoria that deserves serious attention. It is something called the overview effect. Weightlessness in space affects everything from the physical and psychological health of the astronauts to the physics of using all the mechanical equipment of the spacecraft. However, weightlessness in space is not due to a lack of gravity. Astronauts orbit Earth less than 300 miles up, called LEO, low Earth orbit. There's plenty of gravity in low Earth orbit. The Earth's gravity keeps the Moon in orbit, and the Moon is about 250,000 miles away. In fact, a 150-pound astronaut would weigh 142 pounds in LEO. Weightlessness in space is due to free fall, not lack of gravity. What goes up must come down. The rocket blasts off, and about 8 minutes later, the engines shut off. The spacecraft begins to fall back to Earth. Fortunately, by this time, the rocket has achieved orbital velocity, which is about 17,500 miles per hour, so that it falls towards Earth but never hits the Earth. It keeps falling and falling around and around, precisely in the same curved path as the surface of the Earth. It's in orbit. It is free fall. Even though everyone calls it zero-G, it's not. If you were to place a bathroom scale under your feet when in free fall, it would show 0. You would weigh nothing. That's because the bathroom scale is falling too. The exciting thing is that astronauts retain all their muscle power. Their mass stays the same. Therefore, they can lift heavy equipment in space that would weigh hundreds or even thousands of pounds on Earth. Astronauts become superhumans in space. And that creates another unusual situation. There are lots of unusual situations in space. On the very first trip to the Moon, the Apollo 8 astronauts were not even scheduled to look back and photograph the Earth. Apollo 8 astronauts took only a limited number of pictures of Earth. That's unusual and kind of weird. But Earthrise from the Moon became perhaps the most influential environmentalist picture of the 20th century, and it wasn't even planned. But this is the key to understanding the overview effect – surprise at the unexpected. Even today, almost all globes of Earth are not of Earth. Globes in schools and libraries show each country, usually in different colors. Each country, sure enough, contains a star, but it is to mark the capital city of that country. It is not how the Earth looks from space. These globes are not globes of the planet Earth. In fact, it isn't easy to even find a globe of the planet Earth. Read the labels on these classroom globes. The geopolitical world. These are globes of a place called the world. There is no planet called the world. The world does not live in space. It lives on someone's desk or shelf. The definition of space is geological in origin. Space is defined as existing up to, but not including, the atmosphere of Earth. Earth isn't even an astronomical object. It explains why the very first mission to the Moon, the Apollo 8 mission, had not scheduled any pictures of Earth. Selfies weren't invented then. It also explains why the psychological impact of seeing Earthrise from the Moon was so profound. It was a unique and totally new perception for which any and all humans were utterly unprepared. Seeing Earth in space was a complete surprise. Imagine yourself floating in space outside the spacecraft. You are surrounded by the Milky Way galaxy blazing with millions of stars. The planet Earth is a blue marble passing beneath your feet. Pretty heady stuff. How would you react? Would it change you? Apollo 9 astronaut Rusty Schweickart felt strongly that he was what he called the sensing element for humanity. What does he mean? It's the overview effect kicking in. Schweickart felt that he was connected to all the people on Earth. He compared it to being born into a new existence. And astronaut Schweickart is not the only one who felt the overview effect. Apollo 14 astronaut Edgar Mitchell had this to say about being in space. It was rather an extension of the same universal process that evolved our molecules, and what I felt was an extraordinary personal connectedness with it. I experienced what has been described as an ecstasy of unity. I not only saw the connectedness, I felt it and experienced it sentientally. I was overwhelmed with the sensation of physically and mentally extending out into the cosmos. Some years after returning from space, astronaut Mitchell started an institute to study the brainwaves of people who had been in space. And yes, they are different. According to Mitchell's institute's research, the euphoric sensation of oneness with the universe creates brainwaves similar to meditating monks. Mitchell's studies were so significant that NASA launched a special Space Shuttle mission in 1998 just to study the effects of space on the brain. The Neuralab mission studied brain cells of laboratory animals, and the astronaut crew too, as brain cells try to adapt to the freefall environment in low Earth orbit. Well, we can't all be astronauts, but now we can all access virtual reality experiences of what the astronauts saw in space. The internet has opened up our earthbound point of view to share the unity and oneness of the overview effect, and give us a small taste of the space euphoria astronauts get in space.
Our moon could be hiding way more pockets of water than scientists used to think. Its surface has something called cold traps. Those are areas that are in permanent shadow. If you could stand near one of the moon's poles, especially the South Pole, you'd see such shadows all over the place, 15,000 square miles of them. There are tiny cold traps that are only 0.4 inches wide, and there are hundreds and thousands of bigger ones. These regions are in eternal darkness and might have even gone without the slightest ray of sunlight for billions of years. And now, scientists think they're hiding much more than we thought, including small patches of ice, no bigger than a penny. But still, something astronauts could use to drink or for their rocket fuel. The majority of the water could be stored in glass or somewhere between grains on the surface of the moon. One theory says 15,500 square miles of the lunar surface could have the capacity to store water. But no one can prove it until someone goes there in person or sends rovers that would dig under the surface. The moon is not entirely white and devoid of color. Apollo astronauts that landed there in 1969 said the moon was a bit brownish. Later studies showed some dark lunar areas display hints of brown and blue. Highland regions are yellowish, with faint traces of pale and pink. Colors are not the same everywhere because of different amounts of various metals that are present on the moon, like titanium or iron in the surface minerals. Our eyes are not sensitive enough to pick out such differences from this distance. But the majority of the lunar surface consists of minerals that are naturally gray, and that's mostly the color we see from our planet. When you're in space, you can't walk on the ground. No gravity, so no need to wear shoes. That's why astronauts mostly wear socks, or eventually add another warmer pair if they're cold. But something strange might happen to your feet while you're up there. First, if you have calluses, they may fall off after some time. One astronaut described his experience and said the bottoms of his feet became very soft, while the skin on the top of his feet became very rough, like alligator skin. He engaged the top of his feet to get around when he was using foot rails on a space station where they stay. It's not easy up there. Astronauts on the International Space Station, ISS, have to use foot rails and loops to remain steady. When they have to do regular things, like just getting a haircut. When they want to do training, they can strap their feet into sneakers on the exercise equipment. It's essential for them to exercise way more than they'd have to on Earth, around 2 hours each day, because the human body isn't used to moving or performing any actions we normally do without gravity that kinda holds us together. Plus, if you stay in space for a longer time, you can lose much of your bone and muscle mass. For example, you can lose almost 20% of your muscle mass if you spend only 11 days in zero-gravity conditions. But if you were up there, there's no point in using weights, right? Zero gravity affects them too. Instead, astronauts mostly use a device outfitted with 2 small canisters that create a vacuum and allow them to pull against a long bar. On the ISS, you can also use a bike and a treadmill. Did you know that NASA spent millions of dollars developing a pen that you could write with in zero gravity? A pencil is not the best solution for space travel. They have a habit of breaking and shattering, which can leave graphite dust behind. Also, they're wooden, which brings a high risk of fire in the pressurized, oxygen-rich capsule. That's why even such an everyday thing as a pencil can be life-threatening in space. So, they had to develop the space pen. It writes crisp and clean, and can't rely on gravity to make the ink flow. Instead, it uses compressed nitrogen to force ink out of the nozzle. This way, you can write while you're floating upside down, or even submerged underwater. Even when they're up in space, astronauts still face everyday things, like that unpleasant itching sensation on their faces. They can't just satisfy it while in their spacesuit. They need to improvise, so sometimes they scratch the spot with a microphone attached inside of their helmet. Sometimes they attach patches of Velcro inside their helmet for such things. One of the most complicated issues with space trips is how to protect astronauts from space radiation. Our body has not evolved to handle proton storms and cosmic rays coming from the sun. Of course, spacesuits and the rest of the equipment are essential. Some research also showed an antioxidant-rich diet that usually includes a bunch of vegetables like spinach, tomatoes, and beetroot is promising when it comes to reducing the bad effects of radiation. Astronauts didn't always wear white spacesuits. During NASA's first manned spaceflight project, called Project Mercury, they had silver suits. But none of the astronauts went out and explored the vacuum of space back then. Silver is not a good color for that, because spacesuits have to be highly reflective. White is the best for that. That color is the most effective for reflecting radiation while in outer space. We're on Earth, which means the atmosphere is like a shield that protects us from 77% of radiation coming from the sun. But astronauts don't have such protection up there, and this means they're very vulnerable to severe sunburn and extremely high temperatures. A white spacesuit helps, the same way as white paint on your walls helps you keep an entire room cooler. A lighter color will absorb 35% less heat. White is not the only color in their closet. When heading into space or coming to Earth, they sometimes wear a bright orange suit. It's a color that attracts attention, so if anything goes wrong during landing and astronauts have to quickly leave their ship, the rescue crew will spot them more easily. But times are changing, so today we have more sophisticated tools to locate astronauts that need help, such as GPS trackers and transponders, so suits don't have to be orange anymore. Floating through space. Everything's peaceful, and you're enjoying the magnificent view of the dark and quiet infinity filled with billions of stars, planets, comets, suns, moons, and so many other things we'll probably never even discover. 95% of our universe still remains a mystery to us. But at least the view is awesome. But it's only good if you're tethered. What if something goes wrong on your spacewalk and you detach? The whole scene goes from a beautiful dream to a nightmare in a second. But don't worry. NASA has designed a special jetpack called SAFER, Simplified Aid for EVA Rescue. It fires compressed nitrogen from 24 thrusters, which is how it can steer the astronaut back to safety. In theory, you could vent some gas from your suit too, or maybe throw a tool in the opposite direction, which is how you'll push yourself forward. But it's tricky because you'd need to throw it precisely in line with your center of mass. Otherwise, you'll just start uncontrollably spinning, and before you know it, you'll become so disoriented you'll have no idea where to go, even if you could. But SAFER will automatically detect rotation and use its jets to help you stay oriented towards the safe spot. It took scientists 10 days to teach a goldfish to drive a car. They taught it to move its own tank towards a certain target, and in return, the fish gets a treat. This research could help us navigate through space one day. There has to be some mapping happening in our minds. That's how we potentially link our body parts and movements to changes we go through when we're in space. That's how we'll know how far we can extend our arm to reach for a cup of coffee without going too far and knocking the coffee over. The movement control is not the same as under the force of gravity, and we need to be sure if such maps in our brain differ between sea and land, or if it's something universal. So when I say scientists taught a fish to drive, that basically means if the fish saw a target, it should touch the wall of the tank facing the desired direction. That way, scientists could guide the wheels and move them where the fish wanted to go.
At a distance of 640 light-years from the Sun, scientists discovered planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turn to it in the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But on those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the moon's full diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf. And the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests that there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees. That's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that we could fill all our oceans 140 trillion times over, slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans thousands of times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there might just be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on two legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? Hey, I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood.
The constellation Orion is the brightest one in the sky. Orion is also in the night sky during the winter months when it's dark for the most hours. This makes Orion the most recognizable constellation to almost everyone in the world. Most stars don't seem to move too much or change their positions in the sky. This is not because stars are static. It's because our sun is moving along with them at about 483,000 miles per hour. It's a grand parade orbiting together around the Milky Way. The three stars that form the asterism, or star picture, of the belt of Orion have appeared in the same position for many thousands of years. There's a theory that the ancient Egyptians used the belt stars of Orion as a template for the placement of the 3 pyramids of Giza. The brightest star in Orion's belt is the middle one, called Al-Nilam. That's where the 481-foot-high Great Pyramid of Khufu was placed. To Khufu's west side, and in precise alignment with it, stands the 471-foot-tall pyramid Khafre. That's exactly where the star Alnitak is directly aligned to the bright middle star of the belt. To Khufu's east side, where the dimmest star of Orion's belt, Mintaka, is slightly offline with the other 2 stars, is the smallest pyramid of the 3. Menkaure is 213 feet high and slightly offline from the other 2 pyramids. This one example serves to illustrate the profound impact that the constellation Orion has had on human history. Orion's heroic-sized figure inspired the ancient Greeks to create a tapestry-like story. It involves 6 other constellations spread across the winter, spring, and summer sky. Let's see what this story tells us. Orion is pictured as a hunter. Back then, hunting was a big deal. Hunters supplied food. So there's a lot attached to this constellation, the whole food chain in fact. In the sky, Orion is in combat with the constellation Taurus the bull. Except, Taurus is not really a bull, it's an auroch. Aurochs are extinct now, but they were once plentiful in Europe. Standing 6 feet tall at the shoulder with long pointed horns, aurochs were powerful and fearsome creatures. There's a cave in the country of Spain that is filled with gorgeous paintings of aurochs. These pictures date back to 15,000 years ago, exquisitely drawn with inks that have not faded over the course of 150 centuries. The bulges in the rock stand out in 3 dimensions as the shoulder muscles of the aurochs. The constellation of Taurus, the auroch, is also in the cave, with the famous star clusters, the Pleiades, on its back, and the Hyades on its snout. The internet has a thrilling virtual tour of this Cave of the Bulls, full of aurochs. Maybe it should be renamed into the Cave of the Aurochs instead. Recently, the full DNA signature of an auroch was recovered from a well-preserved auroch skeleton, and scientists hope to breed these animals back into existence. Good luck and best wishes to this attempt to revive an extinct species. Aldebaran is the bright red giant star that marks the eye of Taurus. Bulls, when angry, always get this blood-in-the-eye look. Does it make you wonder why the bullseye on a dartboard or archery target is always red? Creeping up behind Orion is Leo the lion. Lions don't just live in Africa in times long past. The Cave of the Bulls in Spain has a painting of Leo the lion. Yep, these prehistoric people were drawing the constellations of the zodiac. But that's another story for another time. Orion gets rid of both Taurus and Leo. And then the story gets interesting. Orion claims in his moment of triumph, "I can defeat any animal I want." Orion's boast becomes the center of this sky drama when Gaia, or Earth, decides to get involved. Orion's words resounded throughout the world. This may be at the time in prehistory when civilization was changing from a nomadic hunter-gatherer tribal society to an agrarian society. The latter developed villages and towns 12,000 years ago. The human population was increasing, and food supplies were diminishing. Something had to be done about Orion and all the hunters, or social development would be stymied. Now enter Gaia into the story, but not into the sky. There is no constellation of Gaia in the sky. Gaia is Earth. Born parentless directly from the elemental chaos, Gaia was the feminine personification of our planet, and the word itself means soil. Brightsiders may be interested in a modern scientific theory that also personifies Earth as a living organism. It's called the Gaia theory. It first appeared in the 1970s. The Gaia theory presents Earth as a biosphere, as if it were alive. The theory claims that all components of the planet work together as one totally interconnected dynamic system. This is called symbiosis, or synergy. Together, they produce the ideal conditions for life. Life adapts to regulate the atmosphere at 21% oxygen, the salinity of the oceans at a maximum of 24.7%, and planetary temperatures at 57 degrees Fahrenheit. To illustrate how life adapts to maintain control of the changes in planetary temperatures, the authors of the Gaia theory created the fictional planet Daisy World. Daisy World is completely covered by white and black daisies. When the sun becomes too hot, the black daisies start disappearing, while the white daisies increase in population. The whiteness of these flowers reflects sunlight, and the planet cools down. If the sun isn't hot enough, the white daisies reduce their population, and the number of the black daisies grows. The black flowers absorb sunlight, and the planet warms up. This is Gaia at work. It's basically the same principle that created oxygen and produced the ozone layer in the atmosphere. This layer helps to block the harmful ultraviolet light from the sun. Scientists have been slow to accept the Gaia theory because of the lack of convincing evidence. But these days, we have self-learning AI supercomputers. They can probably make it possible to integrate Earth's biological and geological systems. This way, we might get a clear picture of how the planet functions as a self-sustaining biosphere. Wouldn't that be something? Now we can go back to the story of Orion and see how Gaia took care of the problem Orion's boast created for the planet. Obviously, Gaia couldn't send animals fiercer than a lion or an auroch to subdue Orion. So, Gaia went small. She chose a poisonous scorpion to do the job, and it did the job. In the summer, the constellation of the Scorpion crawls at almost the same latitude as Orion's foot. The scorpion may be a small animal in the same arachnid family as spiders and ticks, but in the sky, Scorpius is the 33rd largest constellation out of the 88 of them. There is a general rule that the larger a constellation is, the longer ago it was created by early star watchers. They had their pick of stars, first come, first served. And so, they made large constellations first and little constellations later. By the way, if you were the first in line at a buffet dinner, wouldn't you take big helpings and let the end of the line have the scraps? Think chocolate cake. Oh sure, I'll only take a little piece. Nah, I don't think so. In this story of Orion, we have a collection of large conspicuous constellations like Leo, Taurus, Orion, and Scorpius, which confirms the great age of the story. 3 smaller constellations, Lepus the Hare, Canis Major, and Canis Minor, Orion's 2 hunting dogs, complete the Orion star tapestry and add an interesting subplot. What we have then is a fable of 2 different worldviews or cosmologies, that of Gaia and that of Orion. One is feminine and the other is classically masculine. One is committed to dominating the natural world, that's the Orion archetype. The other is committed to the survival of the planet against all circumstances, that's Gaia. The 2 may seem opposed, but perhaps they're meant to be complementary. Look, Orion and the Scorpion are on the opposite sides of the sky, one in the winter, the other in the summer. They act like 2 poles, north and south, of the same magnet, our planet. This is what we see happening these days. Science and technology are becoming more and more sensitive to the natural environment. Myriads of satellites are monitoring the biosphere of Earth. Gaia and Orion are starting to work together toward what the ancient Greeks called kalokagathia, or harmony. That's what we call synergy and symbiosis these days. Let's keep that synergy going strong. You're sitting at a coffee shop on Mars, keeping your head down, trying not to draw any attention to yourself. It's crowded, and many people are singing, dancing, and talking loudly about life on Mars. Your drink arrives, and you sip on it. So far, no one recognizes you. You're wearing a cloak with a large hoodie to cover your face and disguise yourself from everyone. Someone accidentally bumps into you and sees your face. The music stops, and now everyone is staring at you. You have nowhere to hide or run. You ignore the leering eyes and keep sipping on your beverage. An old bearded man sits in front of you, amazed to be in your presence.
So, it's true. No one believed you'd make it,
he says. You don't reply and continue with your drink. Everyone else gathers around you. Another man speaks.
Well, are you not going to tell us how you escaped from the clutches of the space kraken?
Everyone gasps in shock. No one has ever made it to tell the tale of the kraken, except you. Your plan was to find your messenger to take you to a spaceship far away from this planet. But it's too late, now that everyone knows you're here. And the messenger fled, knowing all the attention was on you. You lay back your hoodie and explain what happened. 2 days ago. You're in your full gear, ready to make the voyage into deep space. You have a solo ship that's designed to maneuver through all the obstacles in space. You prepare the rest of the gear and fuel up. Everyone is watching you, knowing that you might not make it back. But the Kraken has been floating in space for too long, disrupting shipping containers bringing in goods. A small ship like yours can sneak past its acute sense of smell and vision. But larger ships will get destroyed. You made it your mission to find this Kraken and study it. If you learn its ways and patterns, you can figure out how to get rid of it. Everyone says their goodbyes, and you lift off. You know that it'll be a very long way to get there, possibly 3 days in the emptiness of space. You saw some quick footage of it, but no one knows exactly where it sleeps, or if it even does sleep. You put on some tunes and set your ship for cruise control. You make some notes and set the camera to document yourself while you prepare everything you need. You also have some cameras outside recording everything that moves, even thermal sensors to catch living creatures floating in space. After a few hours, you exit the safe quarters of Mars and enter into the hostile territory. There is no place to hide or anyone to help you. A few little ships like yours pass by now and then. They watch you going further to the Kraken. You notice many floating signs powered by machines warning you about the Kraken. The cameras start recording, and you begin your video journal, which is transmitting to your network at home. So far, nothing. It's quiet and dark. Hours pass, and you're just floating in the middle of nowhere. You almost feel like you want to turn around, but then you pick up something in the sensors. You see a large live object nearby. You turn off the lights and slow down your ship. You resume recording and start talking to yourself, explaining everything. The object is getting closer and closer. You move aside to avoid it and latch on to a floating rock, but you still don't see anything. Out of nowhere, you see some glowing jellyfish-like creatures flowing together in a cluster. On your thermal sensors, they appear to be large objects, but in fact, they are just little creatures. According to your studies, these creatures are some of the main foods for the Kraken, so they're probably running away from it. After a few minutes, the creatures float away, and you launch yourself out and turn the lights back on. A few more hours pass, and you still see no Kraken. Suddenly, a whoosh shakes your ship, and you're thrown slightly off course. You notice that a large object has spiked your thermal sensors and left. You keep going and check the playback settings to see if your cameras manage to catch something. You try to look carefully, but it seems like a gust of wind blew past you, which is weird because there is no wind in space. You check the thermal sensors and notice that a large object shaped like the Kraken has zipped past you. It's still around, and it has probably caught your scent. Your system's got some DNA particles and are studying them. After a while, they show that the Kraken's skin can change colors according to its surrounding. Its skin is thick and made up of some cosmic fluorescent material that is new to any creature you've ever come across. The system continues studying it. After a while, the Kraken goes off your radar and disappears. You circle back, trying to find it. People back on Mars can see the data and already have information about its size and skin quality. They even see some footage you've managed to catch. As you continue driving towards it, you open your floodlights, trying to see anything. Your cameras are still rolling. Suddenly, the Kraken changes skin color and appears right in front of you. Its large tentacles flash around, whipping nearby space debris. Its large eye that's as big as a bus looks right at you. It opens its mouth, and you see layers of sharp teeth circling like a grinder. It has a large beak that can break your ship easily. It starts flashing its colors rapidly as a way to warn you. It shoots out some liquid to move in a no-gravity space environment. It's moving towards you until it launches itself. Your ship has an auto force field for protection, but it can't sustain the powerful bite of the Kraken. After only a few seconds, the shield breaks, and your ship spirals down to another planet. You crash-landed in a swampy land. Your ship has survived, but it can't take off. The analysis of the Kraken is ready. It shows that it doesn't need oxygen to breathe, and its DNA is evolving. Now that it got a bite of your force field, it can adapt itself to create a bioforce field of a similar nature. But you crashed on a planet that is foreign to you. You put on your safety suit and observe the environment. The atmosphere is filled with nitrogen and sulfur. You get out and walk around. It has similar gravity to that of Earth. As you venture through the swamp, you start seeing little skin particles similar to those your ship has caught. The liquid below you is some foreign substance that seems to be deteriorating your suit, so you opt to hover. The trees are strange and seem to be living off the atmosphere, but there is no sign of life anywhere. Suddenly, you see a huge crater that leads to the center of the planet. You enter it and see some ships similar to yours. It seems that the Kraken knocked them off course, and they all crash-landed on this planet. Many of them seem to be intact, while others are completely obliterated. Your sensors pick up another reading. It senses another creature dwelling in the center. You try to get closer. You're doing your best to be as gentle as possible, but you feel the ground shaking below you. You duck down and try to avoid the rocks falling overhead. A large tentacle pops out of nowhere, and then another and another. It swings itself out and crawls in the open. According to your system's studies, this Kraken is 10 times larger and even looks different. It doesn't spot you, but it can sense that you're around. It starts thrashing the planet, trying to find you. It knocks your ship. You try to find a way to start it, but it's missing a piece. You find another abandoned ship and take out the part that you need and put it on your ship. Your suit has an auto repair function that allows you to fix your ship without the tools. After a few minutes, it's ready for takeoff. You power up your ship, even though it's damaged, and lift off. You manage to sneak past the Kraken. Everyone at the coffee shop is silent. Many don't believe your stories. They had stopped receiving live transmissions before you were knocked off by the space Kraken. Out of nowhere, an alarm rings and warns that the Kraken has arrived. Everyone rushes off in a panic. You hear a voice in your head. It's a bunch of gibberish, but you start getting visions of the Kraken talking to you. It knows you're here, and it's coming for you.
Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023, although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh, well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing: organic molecules. The galaxy in question has a long name, SPT 041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name: a polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part: they're considered the basic building blocks for life. Imagine that, life's building blocks. Those tiny carbon chains being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched, and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future.